Hello, my name is Michael Kinsey, and in this presentation I'm going to give an overview of the research we've done looking at evacuation modelling, cognitive biases, research development and application. The research has been conducted as part of a team with myself in Arup, China, Professor Steve Gwynn at Movement Strategies in the UK, and Dr. Max Kinatedder at the National Research Council in Canada. The motivations for doing the research are on the basis that evacuation models are being used increasingly more in the building design process as part of performance-based analysis, and the fact that evacuation model research, development and application were originally typically conducted by universities or dedicated individuals or research institutions who would actually do the research into how people behave, develop models, and then use the models for a specific application. Now, more commonly, these are typically done by different parties. So university researchers would particularly do the human behavior research. Model development would be done by a company, say, and then the application would be used by maybe consultants or fire engineers. Now, evacuation models are becoming increasingly complex, and there's limited standard guidance available to guide their usage. Now, because of this, it increases potential for mistakes to be made within evacuation modelling. So mistakes can be made for one of two reasons. One is there's finite resources, so there's limited time, mental ability and information available. Another reason we can make mistakes is due to imperfections in the decision-making process. Even with sufficient resources, we can still make mistakes due to how we actually process the information, and that can occur due to cognitive biases. Now, if mistakes occur in evacuation modelling, the consequences of course can be disastrous. It's interesting to note that intelligence can mitigate against making mistakes, but it doesn't grant immunity against making mistakes through cognitive biases. Good examples are depicted in the pictures on the right here, whereby large numbers of people still believe the earth is flat, and this is perhaps because they look out the window and that's all they can see, the earth is flat, and perhaps there is a lack of appreciation of just how big the earth is. Another example is of Mensa, the High IQ Society. They've done surveys of people as part of this society, and large proportions of them still believe in astrology, and this is the belief that looking up at the stars can tell you something about your own future. So we're not just dealing with a small subset of society here. So what we've done in the work is proposed some cognitive biases that might occur in evacuation model research, model development and application. And we've also conducted an online survey to gauge the extent to which evacuation model users might be biased when they're using the model. So your brain can function as if employing two independent but interacting systems. The first we might call the automatic system, or system one. This is typically fast, you do it non-consciously. It's what you use when you have an intuition about something. It uses less energy, it's associative, so it's looking for patterns, and it's typically what your senses use, and you prefer using it. So when you're listening to me now, you don't have a choice whether you understand my words. Your brain is automatically processing it. The same happens when you're reading or doing something familiar. The other type of system is the reflective system, and this is typically done when you have to consciously think about something. Now, typically this is slower, it's based on rules. You're aware that you're doing it, and you can only do it for short periods of time because it takes a lot of effort mentally compared to the automatic system. So for example, when you're learning a foreign language, initially you have to really focus on what the words are and perhaps the grammar, but as you gain repeat experience, you then can shift some of that into the automatic system. So in addition to having these sort of two systems of thinking, two systems of processing information and making decisions, even then most decisions we make come with some level of uncertainty, and it's not possible for us to assess all the different variables and all the different parameters we need to make decisions in the real world, because there's just so much going on. So often what we do is we simplify decisions into more simple decisions, or through substitution, and these can be through shortcuts or rules of thumb. Now, typically we do this when we have incomplete information, or we have incomplete knowledge or limited time, or we have known performing rules. And this occurs through substitution. So to give an example, if I were to ask you, how happy are you with your life at the moment? This is quite a complex decision, and it could potentially involve many variables. So what you might do, consciously or unconsciously, is answer the question, how happy are you right now? And then you give me an answer, and that would be the answer to how happy are you with your life. So your brain would have done a substitution, a complex question, for something more simple, more manageable. Now, it's possible we can use heuristics in both the reflective and automatic system. So cognitive biases occur where information is inappropriately processed or overly focused upon at the expense of more relevant information. And this can lead to an inappropriate decision being made. Commonly, cognitive biases occur when we're using the automatic system and using heuristics, i.e. when we're simplifying a problem, we're not consciously thinking about them. This said, it is possible for cognitive biases to occur using a reflective system and not using heuristics. Now, cognitive biases are extremely common, and I'm just going to give some examples here. So, optimism bias is one of the most common biases. So, I've got some examples here. So, it's believing it's okay to eat unhealthy food if you exercise after, when that's a lack of appreciation for just how much more exercise you would need to do, say, to burn off that slice of chocolate cake. There's a lack of appreciation of that. People who just got married believing they won't get divorced. They've done surveys of newly married couples, and about 90+% of them said they don't think they're going to get divorced, when the reality is, in the Western world, about 1 in 2 marriages end in divorce. And then the last one, people buying a lottery ticket each week without full appreciation of how unlikely they will be to win. And we've got some statistics, relative statistics here, whereby the odds of winning the Mega Millions lottery in the US is about 1 in 300 million, but then the odds of getting struck by lightning in your lifetime is about 1 in 15,000. So you see a lot of optimism bias associated with a lack of appreciation of the likelihood of something, and hope being more likely to, because you want a given outcome, you're more likely to think it will occur. So what we've done is we've reviewed through decision science literature different cognitive biases and thought of examples of how we could link them to evacuation modelling research, model development and application. It's interesting to note that, and we've come up with a list of these, and it's interesting to note that whilst we've done this in the context of evacuation modelling, it's possible that we could apply this to other forms of fire engineering modelling, such as structural fire modelling, CFD modelling as well. It's also important to highlight that just because a decision is biased doesn't necessarily mean it will result in a negative outcome. Indeed, in some situations, it can be a positive outcome. So what I've done here is list some of the potential biases that we've suggested within evacuation modelling research, development and by users. This isn't the complete list, but we just give you some examples here. So in terms of research of potential biases, they may include collecting data from an easily available demographic sample, say students, where you do evacuation trials only involving students, but then you go and use the data for a more general population, say an office building. This perhaps in itself isn't an issue, but if you don't highlight this as a limitation, or other people go away and use your data for a more general population, there's clear bias here in how the data is actually being used. We also have the example of having a funding source that requires a given approach, leading to a practitioner to overly focus on the benefits of a product rather than its limitations. So a researcher may be funded by a given organisation which has a vested interest in finding a given result. There's a potential bias here. In terms of evacuation model development, but a bias may occur when a developer develops a component of an evacuation model initially, then searches for research to support the model, giving little or less consideration to alternate opposing research or appreciation there is insufficient research to develop such a component, which can lead, which perhaps suggests it can't be used with sufficient confidence. We know it's very easy to develop models to give the appearance of a given behaviour being represented, but it's harder still to say whether we have enough understanding in the real world to develop such a model. In terms of users, evacuation model users, we've suggested using a model because a practitioner has an experience or obligation to use a given model, irrespective of the suitability of the model. Also, using default values within a model calculation without questioning the suitability of the underlying assumptions. So this idea of using default values within software, is there a bias to use them? So we've come up with a list of potential biases in these areas, and considering evacuation model users were one of the largest groups here, we wanted to focus on them, and we conducted an online survey to gauge the extent to which some of the biases we've proposed exist within evacuation model usage. So what we did was we posed a hypothetical evacuation scenario, evacuation modelling analysis, and we asked them a series of 21 questions associated with evacuation model selection, scenario specification, model configuration, and results analysis and presentation. So what I'm going to do now is give a quick overview of some of the results we've got from that. We had 60 participants in total, 2/3 were male and approximately 1/3 were female. Most participants were aged 20 to 39, so we're dealing with a relatively young population, and this perhaps isn't surprising because as people get older and have more experience in their careers, typically they progress onto more management roles where then they're not actually doing the evacuation modelling themselves. So evacuation model as a user base we might expect to be typically relatively more young. Participants came from a variety of global regions, with about half coming from Europe. 2/3 either received informal training or were self-taught in how to use the evacuation models, and just under 1/3 reported having attended a university course, and under a half also received some kind of in-house training. Almost 1/2 of participants stated they were proficient in using 2 evacuation models, and they could only use, and about just over 1/3 stating they could only use 1 evacuation model. Over half of participants stated they had less than 5 years experience. So again, this highlights the fact that we're dealing with not only a young population but a fairly inexperienced population when we consider other forms of engineering. So the first sort of section of questions we wanted to ask was about model selection, and we're really interested to see, are there any biases when people choose a model? And what we found out was just over half of participants stated they would consider which evacuation model to use. Now just over half have access to only 1 evacuation model. So what this highlights is that initially we thought, well, we want to try and tease out these biases why people choose certain evacuation models, but what we found is that only over half of them only have access to 1 model, so there's no actual choice per se. They're being biased to use a model because of some other reason. We had just over 1/3 of participants have access to 2 to 3 evacuation models. So I think this is quite an interesting finding, because it highlights that a lot of people don't actually have a choice of which model to use. It's imposed on them by company constraints, and this is probably because there are limited resources in terms of software licensing, costs of training, etc. So this highlights that there is a bias, but it's not necessarily due to ignorance or lack of consideration of information. It's imposed on people. Of the participants which had access to more than 1 evacuation model, just over 1/3 stated they would use the model which was most suitable, and around a half stated they would either use the evacuation model they most frequently used on past projects, or they would choose the model they have most experience with. So what we're seeing here is a clear bias by a sizable portion of users to use a model, even though they have a choice to use other ones, based on familiarity. And this familiarity bias is something that it seems to be quite well prevalent here, where you look at the proportions of people. We also asked a series of questions regarding scenario specification because we wanted to identify any trends in the selection of which evacuation scenarios they would use and any associated biases. The large majority of participants, almost 90%, stated they would likely run more than one evacuation scenario, and there's a widespread understanding of the need to consider multiple scenarios, with a small minority saying they would only run one scenario. Of the large majority of participants who would run more than one scenario, 3 factors were most frequently identified. The first was exploring the impact of stairs and doors being blocked due to fire or smoke. Second, exploring the impact of different demographic groups. And then the third was looking at different pre-evacuation time distributions. These factors are expected to potentially heavily influence most evacuation scenarios. And this is highlighted in the SFP handbook. So generally the results here suggest that there's a range of factors people would consider when exploring the sensitivity of the design, and there's no over-biased on only looking at one scenario. But there is a small proportion that would still be biased here. When we look at model configuration, this typically requires users to decide what parameters are correct and appropriate to include within an evacuation model. And what we wanted to see was whether there was any bias in the selection of these parameters or the adoption of them. So over a third of participants stated they would always or most of the time use the default walker speeds within an evacuation model. And over a third stated they did not know the study or reference for the default walker speeds. So what this highlights is that there's a number of users of evacuation models that will use the default walker speeds very commonly, but they won't know what the study or reference is. And this could be an issue because it can perhaps highlight they're not aware of the limitations of the study, and they may be using it in situations where it's not appropriate. Of the participants which stated they did know the default source, they were also asked to name the study because we wanted to actually push them to see if they actually really did know the study. Now, of those participants, almost a half actually could not name the study where the default walker speeds came from, even though they actually said they did. We also noticed that people with 5+ years experience were more likely to state the study, which as expected. So we're not entirely sure the reason why a number of participants said they knew the study but actually didn't name it. It could be that they perhaps couldn't recall it at the time of the survey. It could be that they were overconfident in stating it, and they knew they should be aware of the study, but they actually couldn't mention it. So what we see here, the key finding here is there's a clear bias for using the default values within evacuation models, specifically walker speeds. More generally, we asked participants if they would use the default settings within the evacuation model, not just walker speeds, but other settings. And again, about half of our participants stated they would likely do so. So again, it highlights as a clear bias to using default values within evacuation models. And this is some food for thought probably for evacuation model developers who are specifying these default values to think about, considering that users are more likely to use them. We also asked participants if they would likely run multiple repeat simulation runs. We know that many evacuation models use random sampling, so when you repeat run the simulations, they'll produce slightly different results. And it's an interesting topic of research at the moment. How do you decide how many repeat simulation runs you run? So out of all the participants, almost 90% say would run multiple repeat simulation runs, with only a small proportion saying they would only run one repeat simulation run. When we asked the participants how would you decide the number of repeat simulation runs they should run, we had 44.2% said they would measure some output variable or variables or series of variants of the repeat runs until the level of variance stabilized. Number 2, we had 18.9% run a predefined fixed number of repeat runs based on guidance, and then 17% say they would run a predefined fixed number of runs as this is what they normally did. So the interesting thing for us here, when we're looking at bias, is number 3 here. There's a number of people that would just run what they've previously done in the past, and again that could be due to some level of familiarity. When we look at results analysis, we're attempting to establish if there any bias existed regarding the graphical realism and implied reliability of the results. Now, many evacuation models employ really realistic looking animations of people evacuating, and what we were interested to identify if there's something called halo bias here, whereby people see a visually realistic looking person, then they're more likely to believe that the underlying behavior is more realistic. So the first thing we need to ask with these questions is, do you think your evacuation model is visually realistic? And the large majority, over 80%, said they do. We then asked participants, do you think because your evacuation model is visually realistic, it gives you confidence in the underlying behavior is more realistic? Now, the obviously correct result is no, it doesn't, or you don't know, because visual realism doesn't equate to modeling realism, as it were. Now, over 2/3 of participants stated it didn't give them confidence, or they were not sure if it gave them more confidence. So this is a large majority of people are getting the right answer here. However, there's just under 1/3 still that said, because my model looks realistic, the underlying simulated behavior is more likely to be realistic. And this is a bit of an issue for us, because it shows that we're getting visual realism bias, as it were, due to halo effect. So in summary, we've given an overview of the general decision-making theory. We've proposed some potential evacuation cognitive biases within research, development, and application. We've conducted a survey to demonstrate and quantify the extent to which some of the biases occur in evacuation modeling. And we've identified common biases which occur by evacuation model users are default biased and familiarity biased. We clearly need to do further research to address some of the limitations of the survey, predominantly because we're relying on people to self-report and tell us what they would do. A way to address this could be through experimental trials. Thank you very much.
Michael, we have a first question here from Kristen. Do you think that there is sufficient variation between the models that were being used by the people surveyed, that familiarity wasn't a good reason to choose a model, like i.e. all the models had a similar level of suitability?
Yeah, I think this is a good question. Indeed, you could argue that are all models similar enough that the selection has very immaterial difference on the outcome and the results. You know, are they all good enough, as it were? That's something we don't know, I would say, and it would really depend on the model. We didn't question them. I mean, I think in hindsight, I guess it would be interesting to ask what model would you use, and I think we eventually agreed that we wanted to try and focus on the other things other than that. But I don't know, Max, if you wanted to add in anything.
Max looks like he's just a little bit frozen there. So Max, if you need to drop and come back in, you can do that. Yeah, let's go on to the next question. So Enrico, is it reasonable to say that people seem to use more of the models they learned in school?
Well, if we, I guess if we ignore the people that have only access to one model, I think that's probably one of the biggest findings. People just don't have access to more than one model. We can definitely see a familiarity bias to use certain models, the ones that they're more familiar with. So absolutely, if they've learned something, if they've learned one model in school, then they're more likely to want to use it given a choice in industry.
Yeah, I suppose it's probably fairly heavily driven by what your company purchases. It's probably the big one, what you ask for and what's purchased and available for you. So yeah.
Exactly. I mean, it's interesting. It begs the question of. Sorry, Max, go on.
Can you guys hear me? Oh, it's also reflective of like a lot of the training happens informally. So it seems like that the development of those models and the availability of those models has not seeped in very deeply into university courses, for example, and that may not just probably on the job.
That's interesting.
I mean, it's a common tactic by software developers to make licenses available free for universities. They do this with Microsoft development stuff as well, trying to encourage developers when they hit the industry to start using them. So it would actually just seem a really great idea, you know, that the more developers that can make their models available to universities, you know, at least then that could increase the breadth of models they're experienced to, I guess.
So Max, I'm going to remove you from this. No offense, but your connection's just a little bit spotty, so it's a little bit hard, I think.
Sounds good.
Okay, so yeah, and we're definitely guilty of free licenses, so like, I get that. How confident? Did you ask how confident people were using the data they submit on their own? An example, instead of default data, how biased can we be when choosing the source? Or how confident can we be after finding the first source that looks credible?
Yeah, I mean, this is something we didn't really explore. And how easy is it? Those that do select them values, what biases happen in model selection? You know, we look at the SFP, the engineering data section, chapter 64 in the SFP handbook, that has loads and loads of data. And the minute you present lots and lots of data to someone, that you can't help but be biased towards certain data when you do repeat analysis. So I think it's definitely, I know the SFP chapter handbook's being updated at the moment, and I think this is probably a real issue. When we're presenting lots of data to users, we need to think about how are they going to use it rather than just, you know, blowing it up and just saying, here are all the tables.
Do you have any suggestions about which output parameters should be monitored in the repeat runs of the evacuation simulations to reduce uncertainty? Is there a certain quantity that's better than another?
I think first of all, I think that we should be looking at variance of some output variable. I think the area of this is still a bit immature, but it's something that, you know, the work of, you know, Enrico at Lund and some others are doing to see what are the best values. You know, initial work started looking at just pre-evacuation time static values, and then we started looking at time series data and functional analysis and things. So it's because it's so complicated, it's very hard to tease out what was the right thing. But I think at the very least for practitioners here, you should be doing more than one single repeat run, and try and use some output variable to at least show you've looked at variance in the output.
Excellent. And let's see, I'm just kind of going through here. Do you see a need to compare results from different models to carry out a better analysis?
I'm not sure. I think from a commercial practicality standpoint, this will be difficult to do in practice, because then effectively all your modelers would have to run everything twice or three times or however many times. There is also a question of which model do you compare. I haven't seen any data suggest there's too much value in running more than one model. This said, if one model does something which the other can't, then there certainly might be value in running an analysis with a given model over another one.
I suppose then it depends a bit on what validation is available too for each model, and making sure, because ultimately comparing model to model is probably not as important as comparing model to reality, some version of reality results, because who is right? If you have two models, which one's more accurate? It's hard to tell unless you have something else in reality to compare it to. So validation seems to be important in that aspect.
Yeah, absolutely.
Let's see, do you think that the people asked about the number of models used perhaps overlooked that hand calculations are also an evacuation model?
Yes, so I'm aware that you can say anything is a model almost when considering how people evacuate. And I think generally in our experience, certainly in fire engineering, models are commonly referred to computational evacuation models, whereas hand calculations are typically analytical calculations you perhaps do in Excel. But I'm aware that, you know, certainly in research, we might call a model, you know, more conceptually.
And then do you know, do you have any ways, any other ways to know about the models scientifically or integrally? They're just, a PhD student here is wondering how to pick a model. Like usually they pick one according to previous experience or their supervisor's suggestions, but is there a methodology at which you should go about selecting one for your application?
Well, I mean, this is a great question. I think there is limited guidance on selecting models. And I think this is something that would be great to be picked up within the SFP handbook. I know, actually, we're writing the evacuation modeling chapter. So this is something I think we can, I think we're looking at trying to think about. And yeah, trying to address, I think. There's also all manner of things other than just, I mean, here we're hyper focusing on how good are they and how, the end result. But at the end of the day, we also have all these other factors that we need to consider, like cost, training, investment for future and things like, and scalability of how much am I going to use it again in the future. But yeah, absolutely, this is something we need to look at.
Great. Well, thank you very much, Michael, for the talk and for the Q&A here. People are welcome to follow up with you directly through the chat function or reach out to you via email. You'll be around hopefully for other sessions and other days, but we've got the next talk on the stage now, so hopefully everybody can transition over there and watch the next talk. Thanks, Michael. Take care.
Thanks, everyone. Bye.